All right, so let's go ahead and work on this EOC stuff. Once I find it, I got way too much stuff open. All right, EOC practice. Homework. All right, I got the 20 last video. All right, we got 21 up. 21 is graph a piecewise function. Now, what you may not realize here, because bless you, is this is y. So this says y is 22. All right. Your less than equal signs, those are closed dots. So as long as x is between 0 and 20, y is 22, and that would be with closed dots. 18 when x is between 20 and 75. Now notice that that's open. So 18 at 20 all the way to 75, counting by tens would be about right there where it stops. The nice closed dot because of the symbolism. All right, between 75 and 100, we're 15. All right, so look at how we count here, by the way. 2, 4, 6, 8, 10, 12, 14, 15 would be just a little bit higher. We got an open dot. We run all the way, that's kind of hard to tell, but that's open. We run all the way to 100. Right there, and 100, we close that dot because of the symbolism. Now we're 13 when we're greater than 100. Open dot because of symbolism, and we just move right with an arrow. All right, 22 is up next. Wouldn't kill you to know how to write an inverse. Now, they actually gave you the inverse, which is kind of funny. You're supposed to find the inverse of this or the original function. This is just another fancy way of saying y, by the way. So we swap x and y, then we resolve y. And in this case, we're actually going to replace y with f of x because we're finding the original function. They gave us the inverse, go the other way around. So we're going to replace f to the negative first with a y because that's what she is. And let's see here, we have the cubic root of x plus 4 plus 15. Now we're going to do this step right here. We swap x and y. She becomes x equals 1/2 of the cubic, I don't need the parentheses there, sorry, of the cubic root of y plus 4 and outside plus 15. We're going to do easy things first. The easiest thing you can do is subtract 15. So x minus 15 is the 1/2 the cubic root of y plus 4. Now the opposite of multiplying by half is actually multiplying by 2. And I'm not even going to do the distributive property of 2x minus 15. That's just not going to do it. It's going to give me 2x minus 2 times x minus 15 equals the cubic root of y plus 4. The opposite of cube rooting would be to cube. So I have to cube everything here, including the 2. That's going to give me 8 times x minus 15, all cubed, equal to y plus 4. And then I'm just going to move 4 over. 8 onto x minus 15 cubed minus 4 is my y value. And the last step would be to replace that thing with what she actually is, and she's the original function. Because they gave us the inverse, we were finding the original. Moving on, 23. Select all the products that are defined. So for matrix multiplication to work, the number of columns must match the number of rows. Now I'll expand on that. So if I look at example A, they're telling me to do x times y. Well, x is a 2 by 3, and I'm trying to multiply it by y, which happens to be a 3 by 2. So the insides match, we're good to go. If the insides match, you're good. Talk about x to z. X to z, we are taking a 2 by 3, and we're going to multiply it by z, which is a 1 by 3, and that's a no-go. Because this, no, doesn't happen. Z to x is a 1 by 3, and we're trying to multiply it by x, which is a 2 by 3. If you look in there, doesn't happen. Z to Y, you're taking a 1 by 3 and you're multiplying it by a 3 by 2. We're good to go because the inside numbers match. And finally, Y is Z. And you'll notice I'm talking about the one they talk about first. Y is a 3 by 2. And we're trying to multiply it by Z, which is a 1 by 3. And again, I look at the inside, they don't work. So just A and D. 24, describe the end behavior of the polynomial function. Now, first off, this thing needs to be in STD form for it to make sense, for you to approach it from the classical point of view, which is 3x cubed plus 2x squared plus 4x plus 1. This is what we call the power function. In a perfect world, this would be on the non-calculator part of the EOC. But 3x cubed, if you think about x cubed, think about your x to the odds. Remember those guys? Starts low, ends high. So as x approaches negative infinity, y approaches negative infinity. That is true. As x approaches negative infinity, y approaches infinity. It's not going up. That's false. As x approaches infinity, which means we go right, this says y is supposed to go down, but it doesn't. False. As x approaches infinity, y approaches infinity. Now, you know, half of you guys, just bless you, because you just can't seem to grasp anything. Here's the killer. You're going to have a calculator on EOC, and you're just going to be like, ooh, with a little water just you'll be drooling all over your test because you know what's going on here. You could, if you have a TI-84, bruh, you could go to y equals, bruh, and you could push some buttons, couldn't you? I believe you could, bruh. Daggum, it ain't that hard. See, there you go, TJ. That was for you. I mean, how hard is this? Zoom sixth. Like you were trained, man. And you'll see what the function does. And the function starts low and it ends high. If you don't grasp what that is, starting low and ends high, you probably are high. Oh, there's one more on that one. Evaluate 36 to the 5/2. I would not expect you to have a calculator on this. Wouldn't expect it. This is asking you to take the square root of 36, because remember the 2's are understood, and then raising it to the 5th power. Now, it's not a calculator problem. The square root of 36 is 6, and you're supposed to raise it to the 5th. This is what you'd see. It'd be 6 to the 5th. Now, at that point in time, I don't think anybody's asking you to figure out what 6 times 6 times 6 times 6 is. It's not like it's something we require you to memorize. But that's what it is. But anywho, you know, I'll prove to you that's right. 6 to the 5th power should be the same as 36 to the 5/2. But you are expected to be able to evaluate things by hand. But that's a little too big to do by hand. Select all the expressions that are equivalent to x to the 5/3. This is that whole x to the p over r notation. It is the rth root of x to some power, or it is the rth root of x all to some power. We've been over that. So you talk about x to the 5/3, you need to find ways that you can get the same thing. Oh, and they're also doing this guy. This is x to the a to the b, which is x to the ab. So look at this. I don't like how they wrote the exponents here, but you would have x to the 1/9 times 15, which is x to the 15/9. And everybody and their mama knows that 15 and 9 are divisible by 3, and you get 5/3. Winner, winner, chicken dinner. All right, don't be the kid who picks that one, because the root is 2. It has a root of 2 because it's a square root, and the 2 is understood, bruh. So no, x to the 15th doesn't make a lick of sense. 15's over a 1. It doesn't make any sense. This is what it is, obviously, because here's your root, and there's your power. And they've got it backwards. Oh, no, 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 no. Bad Milbrath. Good one, because I would do something like this. This is the power, this is the root. This is x to the 3/5, ain't it? Choice E is the right one. So it was A and E when everything was said and done. All right, here you got you a square root. You're supposed to find the solution. Lots of ways of doing this one. I'll show you 3 different ways to get her done. It just depends if you have a calculator or not. Of course, the first thing is, because I teach algebra, is to do it algebraically. So we're going to go ahead and we're going to move that over here. And this would actually be where I stop. This has no solution. Why? Because the square root of a number can't be negative. It's done. It is. You know, even if you just go through here and you do, like I said, I'd show you 3 ways. So if you like take a -2 and plug it in. So I have the square root of -2 minus 1. My T84 is just going to complain, right? By the way, we're supposed to equal 2. If I plug a 4 in, I'd have the square root. Notice, oh, I forgot the negative sign. Negative -2 minus 1. And then it says plus 3. I'm supposed to get a 2 back, right? And I got a 4. If I plug in the 4, my calculator throws a fit. And if I plug in a 2, my calculator is going to throw a fit too. That's a square root. There's a negative x, so -2 minus 1, and then add 3. The calculator is going to throw a fit because you're talking about imaginary answers. And the other thing you could do is you could go to y equals. You could type square root -x minus 1, arrow out, plus 3, put a 2 on the right-hand side, do a zoom 6 as you were trained, and here comes the square root function, and there comes 2, and they don't intersect. There's no solutions. 28. You are expected to do these without a calculator. You really are. It's C minus D. So what's 1 minus 10? Well, that's -11, which basically throws away A and C. Now, I notice they differ in this element too, so I'm going to figure out what -7 minus 6 is, and by golly gee, wow, that's -13. That leaves choice D. Easy peasy, lemon squeezy. 29 is going to be a rough problem for a lot of kids. Let f of x be 5x minus 2. Let g of x be x plus 1 squared. Find g plus f of x. Let's start with that. G plus f of x is literally to take g of x, which is x plus 1 squared, and add to it 5x minus 2. Now, you have been with me since August. To square something properly, the only way you can do it is to write it twice. That's the only way to do it. And then you FOIL, bruh, FOIL. Or you can even go back and do the box. Remember the box? You can do the box. Nothing killing you about doing the box. X times x is x squared. We get an x there. We get an x here, 1. X squared plus 2x plus 1. And then I got to add in my 5x plus minus 2. So I'm going to have 7 x's, I think. 2 plus 5 is 7 last I checked. 1 minus 2 is -1. And that is g plus f of x. Ain't too hard. Next up is f minus g. Order is important. We'll do f minus g of x. So we're going to start off with 5x minus 2 because that's function f. And then we're going to take away this quantity of x plus 1 squared. Now, we just did that work. Just remember to use parentheses. You're taking away all of x squared plus 2x plus 1. And remember to distribute the negative sign. And then remember to combine terms and put it in STD form. You'll have an x squared. You got 5 minus 2 plus 3x, -2 minus 1 minus 3. And that's what that one is. Now, by the process of elimination, this has got to be the answer. But sometimes you don't have to check mark everything. Like that's part of it. This is f of g of x. That means that you start writing down f until you see an x. When you see an x, it becomes g, which is x plus 1 quantity squared. And then there's still the minus 2. Now we happen to know that x plus 1 squared is x squared plus 2x plus 1 because 2 minutes ago we did that work. and then minus 2. If we invoke the distributive property, we will have 5x squared plus 10x plus 5, and then minus 2. And 5 minus 2 is 3, so it worked out. BRB. Now, this is the stuff we just got testing over, right? A flower shop classifies its selection of bouquets by size, color, and occasion. Part A is find the probability that a bouquet selected at random is a small multicolor bouquet, given that it's for a birthday. So first off, this is my denominator. It's going to be over how many things are in the birthday category. So we have 24 plus 22 is what, 46? Let's check my math on that. This is the stuff I tend to mess up. 7 and 13 makes 20, plus 22 is 42, plus 4 is 46. So it's out of 46. And it's going to be a small multicolor, which would be 13. So there's 13 of 46. All right, part B is also a given it's a multicolor. So what do we have here? In the multicolors here, we have 35, and in the multicolors here, we have 24. There are 59 total multicolors. Remember, the given is always the denominator, always. All right, so find the probability that a bouquet selected at random is large and for a birthday. Large and for a birthday, given that it's a multicolor, is just those 22. 22 and 59. Moving forward, which one of the functions is a one-to-one function? So in addition to some definitions I gave you earlier, a one-to-one function passes both the horizontal line test and the vertical line test. Now I'm going to do these by hand, and then I'll show you what they look like in a calculator. So if you talk about A is mx plus b, bro. 1, 2, 3, 4, 5. Rises 4, runs 1. That is definitely a one-to-one function. Sorry, that's choice M, right? Talk about choice P. P is 4x squared plus 5. 1, 2, 3, 4, 5. And then she is a parabola. P is full parabola. So is this guy. It's got that square. It's just been shifted left 5. Remember, plus 5 is left, 3, 4, 5. And then she looks like this. Now, these are failing the horizontal line test. So they are not one-to-one. You guys were not required to memorize this one, but it looks a little bit like this. And it also fails horizontal line test. So it's choice A. A is the only one-to-one function up there. And, you know, some of these, you don't know. If you're holding a TI-84, it's entirely on you. The question was not difficult. You are difficult. It's your hard head that's the problem. So like the one you'd never seen graphed, 1 over 4x to the second. You know, probably some like little like, is Milbrath right about this? Like, I don't know if I trust this man. You know, whatever. Watch this. There's the up 5. I was right, kids. And it fails the horizontal line test. Graph. Always look at graphs. 32. Kenon. I don't know. Use the expression 36 minus 2x times 24 minus 2x to find the area of a rectangular canvas after cutting out an equal size square from each corner. Select all the statements that are true. The original length of the canvas was 36, probably. What he's done is he started with something, looks a little bit like this, and then he cut squares out of the corners. We had this problem. Remember I told you you could make a box that said live, laugh, love, sold at Hobby Lobby for 50 bucks? This was originally 36, and then you cut out 2 x's. That makes this piece. This was originally 24, and then you cut out 2 pieces. Makes it 24 minus 2x. So yes, the original length was 36. The original width was probably 24. The side length that he cut out is an X guaranteed, and there you go. It's expected that a math teacher has talked about these things with you, and I did, bro. I did. I did my job, man. 33, the table shows the number of baseball cards in John's collection. People still collect baseball cards, really. Make a scatter plot of the data. So at 0 weeks, he starts off with 20. In 2 weeks, he's sitting at 32. We're counting by 10, so it's about like right here. In 4 weeks, he's at 37. We got closer to 40. In 6 weeks, he's at 50. That'd be right there. 40, 50, 60. And in 8 weeks, he is at 64, which is going to be somewhere around right here. Now, we're supposed to write a function that models it. I'm thinking it's probably a cubic. What we're going to do is we're going to compare our squared values. I think it's probably a cubic, just by looking at it. So I'm going to go to my TI-84, and the TI-84s that you get on test day will be cleared. I'm going to go to second catalog. I am going to look for something called diagnostics on. You can actually get there quicker by going ahead and pressing that key right there. And I'm going to scroll on down to diagnostic on. I'll press the magic enter key. Now I'm going to put my X's in list 1 and my Y's in list 2. So my X's are 0, 2, 4, 6, 8. And my Y's are 20, 32, 37, 50, and 64. Take it. There you go. 64. If you're a little curious, remember you can do scatter plots too. You can turn them on. Second Y equals, turn them on. Then you can do a zoom 9, all that good stuff. Anyways, none of that matters. I think it's a cubic. All right, so I'm going to go to stat calc. I'm going to do a cubic regression. And I could be wrong. It just looked like a cubic. No frequency list. I didn't do it with frequencies. Press the magical calculate and look at that R squared value, 0.97. It's really, really good. The closer to 1, the better. We're not interested in R, we're interested in R squared. And make some comparisons like, okay, I don't know what a parabola looks like. Do a quadratic regression. And I bet it's not 0.97. I bet it's less. But, you know, what do I know? It's less. Maybe try some other stuff. Like you're like, hey, maybe it's a logarithm. It's not a logarithm. It's not going to be a logarithm. It looked like a cubic. Yeah, go to. Because it's got the zeros. So the only other thing that you might do would be like a power regression. Stat calc. Of course, you can do exponential, but since there's a 0, exponential regression, I think, fails. I think you got to do a power. No, power was the one that failed. Maybe you can do an exponential. Oops. Figure that out. Goodbye. Stat, calc, and I'm not trying to waste your time. I'm just trying to go through everything. Thank you for bearing with me. I know this is boring. I know it is. The highest R squared value I saw was for my cubic. So that's the one I'm going to be. So stat, calc, cubic regression, which is a good chance on your EOC they would do a cubic if they ask you to find it. And there we go. And I just feed the formula. So let's go out at least 3 decimal places. Y equals, that's perfect. That's -1/3. See, plus 4.089x squared plus a negative, not plus, so minus 3.631 x and then plus 0.9142. 0.914. Let's see, I don't like the way this thing is worded, but whatever. Jameson is framing a square picture that has side length 8 inches. He knows the area of the mat that surrounds the picture will be 80 square inches. Write an equation that relates x, the total area of the picture and mat, with the side length of the picture. It's a little easier than the one that was in your notes. Let's see, we have a square picture, and I drew a rectangle, didn't I? I need a square, and it's 8 on all 4 sides. Now, I add something to it, a border. And what I know is I know that the area of the border is going to be 80 square inches. I also know that the area of the picture is 64 square inches. The question is, what did I add? How wide is that border? Suddenly, the sides became 8 plus 2x because we added those two unknown pieces. If I put these two numbers together, I get 144 square inches. And if I talk about the new square, its area would be 8 plus twice x squared, because the area of a square, and this is a problem. Why, juniors, I don't understand. It's because you don't even know how to find the area of a square, bro. This is not a problem for me. This is a you problem. And you don't need to say IDK when you don't know how to find the area of a square. That is something you need to work on and reflect upon, because something's wrong with you. That's how we do it. I don't even mean that mean. It just doesn't make sense to me how you can be a junior and not know how to find the area of a square. You shouldn't be a junior. You should not be a junior, plain and simple. You should be something else. Anyways, to square something, you write her twice. And then you FOIL or write a box. I don't care. 8 times 8 is 64. We're going to have plus 16x there. We're going to have plus 16 more x's there. We're going to have plus 4x squared there. Still equal to 144. We're going to combine like terms, put everything on the left-hand side. 4x squared plus 32x. And we got to figure out what 64 minus 144 is, and that, boys and girls, is 80. It happens to be negative because we shifted left. And we're just going to keep factoring because I love factoring. We can pull a 4 from everything. 4 enters 32, what, 8 times? Got my x there. And now I'm going to keep factoring. Takes an x and an x to make x squared. Factors of 10. 2 and 5, aren't they? Because that's supposed to be a 20. Factors of 20, 10 and 2. 10 is positive, 2 is negative, because the goal is to add to a positive 8 in the middle. So this tells me that x is negative 10, which would be extraneous, or x is 2, which is real. Now, if that x becomes 2, suddenly I have side lengths of 12, because 8 plus 2 plus 2 is 12. And you know what? I did a whole lot of more stuff in here than I was supposed to do. All I had to do was write an equation. So your area as a function of x equation was just to write 8 plus 2x squared. I just went off and wrote a whole lot more. Sorry, waste your time. Using the equation you wrote in item 34, find the total area of the picture and mat in square inches. Well, you don't need an equation for that. It was this answer right here. That's easy. All right, I actually need to be done because 5th period is about to start.